video is about termination and elongation. Let's start with translation. Translation is nothing but mRNA encoded into protein. And here, here conversion of DNA into mRNA takes place into translation. And by the way, translation over of three steps. Beginning step is initiation, and middle step is elongation, and final step is termination. These three steps, initiation, elongation, termination, are used in transcription to describe the steps involved in making the mRNA strand. But in translation, we are making polypeptide strand. Let us talk about initiation. Initiation mRNA is attached to tRNA, which is attached to the specific amino acid. During initiation, the mRNA strand, the tRNA and the first amino acid all come together within the ribosome. The mRNA strand remains continuous, but the true initiation point is start codon. AUG, the start codon, is the set of 3 nucleotides that begins the code sequence of a gene. And also, the start codon specifies the amino acid methionine. So, methionine is the name of the amino acid that is brought in the ribosome first. And here, methionine get itself. How methionine get itself to the ribosome? By attaching the tRNA that contains the right anticodon, and the anticodon for AUG is UAC. It is because the complementary base pairing. The tRNA with the anticodon UAC will automatically match to the codon AUG, bringing the methionine along for the right. There, mRNA is attached to the tRNA, and tRNA is attached to the methionine. This is known as initiation. Next, elongation. Elongation is nothing but bulk of translation is known as elongation, and it is addition of amino acids by the formation of peptide bonds, and a chain of amino acids goes longer and longer. More amino acids are added on. This eventually create a polymer. Here, this is the elongation. You can see that, as you can see that the diagram about each T of the coding strand is replaced with U in the RNA transcription, right? Here we can see that during elongation, RNA polymerase walk along the one strand of DNA known as template strand, right? You can see here template strand, and in the template strand in the 3' to 5' direction. Here we can see that here, and each nucleotide in the template RNA polymerase adds a complementary RNA nucleotide to the 3' of the RNA strand, and the RNA transcript nearly identical to the non-template or coding strand of DNA. However, RNA strands have base uracil in place of thymine, and as well as slightly different sugar in the nucleotide. Here you can see coding strands, RNA template strand, right? This is elongation, and next we have to go to termination. Here it is, as you can see here. Termination is the ending of transcription and occurs when RNA polymerase processes stop sequence in the gene, and one of the 3 stop codons enters a site. No tRNA molecules bind to these codons, and so the peptide and tRNA in the P site become hydrolyzed, releasing the polypeptide in the cytoplasm. The small and large subunits of the ribosome dissociate for the next round of translation. The mRNA strand is complete and it detaches from DNA. As you know, DNA is a genetic. DNA contains genetic information, right? Yeah, here you can see. You can see here termination diagram. Thank you.